This section will cover binary conversion, hexadecimal representation, and the AND operator. When you start working with IP addresses, you should learn these abilities. Understanding networking is important if your career begins to focus more on this area. To build and run a network, you will need to know how to convert numbers between different formats. To allow you to represent larger numbers, computers group these switches together. The one you will encounter most frequently is the byte, which has 8 bits. A byte's value ranges from 0 to 255. I use the following table to translate a decimal to a binary. There is a value assigned to each bit in the table. As you can see, the initial value has a 1 in the first position as you move from right to left. 2 is the value for the second position, twice the previous value. The 3 position has a value of 4. As you can see, the value doubles in each position until it reaches the final value of 128. If I wanted to convert a random number, say 174, into binary, I would do the following. First, I'd go to bit 8 and see if 174 is greater than or equal to 128. If 174 exceeds 128, which it does, the result is a 1. Then I'd subtract 128 from 174 and put the result, 46, in the next column. The next column has a value of 64. 46 is not greater than 64, so the result is no and gets a value of 0. I now move 46 to the following column and compare it to its value of 32. 46 is greater than 32, so I place a 1 in this column and subtract 32 from 46 to give me 14. I continue to use the same procedure throughout the table. When I get to the second last column, you'll notice that the value 2 equals the column value. In this case, the value equals the column value, so the result remains a 1. Because there is no remainder to subtract from the column value, all columns following this will equal 0. This gives us a binary value of 10101110. You can quickly and easily convert any decimal number to a binary number using this method. Because IP version 6 uses hexadecimal in the IP address, you must understand it in order to master IP version 6. If I were to convert an IP version 4 address to hexadecimal, I would do the following. First, I'd use the previously demonstrated method to convert the numbers to binary. The numbers are easier to work with once they have been converted to binary. The binary is then divided into 4 groups of 4. By dividing the bits in this way, each group of 4 bits has 16 different possible values. Hexadecimal uses 16 values, which is where the name hexadecimal comes from. Converting these values to decimal values is straightforward. As you can see, each group of 4 bits has a value between 0 and 15. You can use this table to determine the hexadecimal value once you have this value. As you can see, the first value is 12 and is assigned a value of C. Because values between 0 and 9 have the same value, the values in the example 0, 9, 1, 1, and 3 all have the same value. It is not until we get to the far right that we see the value 14 and the value of E. The value of A will be assigned to value 10. IP version 4 addresses are embedded in some IP version 6 addresses. Understanding IP version 6 addresses requires understanding of how to convert decimal to hexadecimal. Slide 4. When you start working with multiple networks, you must understand how the AND operator works. Consider the following table. When 2 bits are compared, the result is a 1 if both bits are 1. You will notice that the result in all other cases is 0. It only takes 1 or both bits to be 0 for the result to be 0. If you're having trouble grasping this, consider the AND operator to be a multiplication operator instead. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0 and 0 times 0 is 0. Why is the AND operator so important? Later in the course, you will learn how to use the AND operator to determine the destination of a packet. Consider this small network. When a computer sends data over a network to a server, the computer must decide whether the data should be sent directly to the server or via a router. If the server is on the same network as the client, it sends it directly to the server. If the server is on a different network, the client computer sends the data to a router. Your computer can determine where to send the data by using the AND operator. This process will be explained in greater detail later in the course. This has been a brief introduction to decimal conversion. If you don't do much networking, you might want to think about it. You can use the Windows calculator to convert decimals to hexadecimal and binary. Just make sure to put the calculator in scientific mode first. Check the exam requirements before sitting for your exam. Many exams will allow you to use the Windows calculator in the exam. If you intend to take any Cisco exams, you must have a solid understanding of how to convert decimals. Cisco does not provide a calculator in the exam to assist you, and believe me, you need to do the math quickly. Finally, if you need more practice, there are numerous resources on the internet. When I first started learning networking, I went to a website called learntodinchecker.org. This is a fantastic little site that will teach you how to convert decimals to binary as well as how to subnet. Don't worry if you don't understand subnetting yet, I'll go over it in more detail later in the course. For the time being, make sure you understand the fundamentals of binary and hexadecimal. If you don't know how to convert values, you can use the Windows calculator for the time being.